and now we are looking at question 2. We have got a nice experiment with aphids, greenfly, and what you can do is they stick their stylets through the stem and feed on the sugar, and you can collect their excreta, what comes out the rear end, and what a job in biology that is, measuring radioactivity in insect excreta. Radioactivity was first recorded in colony A 2.5 hours after the start, and then in colony B no radioactivity appeared until after 5 hours. Convenient number. So first of all, this is a rate, so it's something that happens per time. So in question 2, the time is 2.5 to 5, so 5 minus 2.5 equals 2.5 hours, and the distance is on there, 63. So the rate is distance over time. The distance is 63 centimeters divided by 2.5 hours equals, so 63 divided by 2.5 is 25.2. And what's the units for that? Well, the distance is centimeters per time, which was hour. Centimeters per hour. We could just double check this, calculate the rate. It doesn't give a unit, so I would stick for that because I don't want to do any more calculations. I'm there. But we could, if it asks for per minute, we could go, well, if it goes 25 centimeters in an hour, so if it goes from there on my ruler there in an hour, then how much would it go in a minute? Well, a 60th of that, so it'd be down here. So do we times it by 60 or divide it by 60? Well, if we've got a bigger number and we're making it into a smaller number, we must be dividing it. So per minute, 25.2 divided by 60 equals, there's my 25.2 divided by 60 is 0.42, and that would be centimeters per minute. But I'd have left it like that if it didn't ask for any specific units. Question 3. In the catalase soaked disc experiment, a disc took 15 seconds to float. That was, we had hydrogen peroxide in there, and then you threw a paper disc soaked in catalase into there. It sunk, then bubbles of oxygen product made the disc rise again, and you timed how long it took to sink and rise. On this it says what was the rate of reaction. Right, okay, it doesn't go how far is it or whether it's sinking or not. It just says the information we've got is 15 seconds for something to happen. Okay, so the information we've got, and I always tend to write these down in questions, write down a summary of information. So got 15 seconds to float. The rate of something is how many times does it happen per unit time. So what happens per unit time. And so we've got one thing happening in 15 seconds. So we want to know how much would happen in 1 second. So the calculation is 1 divided by 15. So we always go 1 over whatever the time was. So 1 divided by 15. 1 divided by 15 is 0.06 recurring. Does it tell us any decimal places to use? No. So 0.06 recurring. And what precision should we use? Well, we've got 2 significant figures there, so I'm gonna use maybe the same or maybe one more. I think either way will be fine here. So I'm gonna use 2 significant figures. So 0.06, and the next one is 6, but the one after that is 6, and so because this is 666 and so on, then that'll be 0.67. The unit says seconds minus 1, which means how many times does that happen in a second? If it takes 15 seconds for it to happen, how many times would it happen in 1 second? Less than 15, a 15th of it. That was a frequent thing in experiments. You express it like that because then it makes it easy to compare. Right, next question. Question 4. An organism has a surface area of 240 and a volume of 125. Surface area to volume ratio. Right, you should have done quite a lot of these by now. So, surface area to volume ratio. 240 to 125. And as this is surface area to volume ratio, it's going, how much surface area do we get in 1 volume? That's what that means. So how much of our surface area do we get in 1 of these volumes? So we want this to be 1 on that side, and this is our mystery, what's on that side. Well, what did we do to this number 125 to turn it into 1? We divided it by itself. 125 divided by 125 is 1. And we need to do the same on this other side here. We need to divide by 125. So our calculation is 240 divided by 125. 240 divided by 125 is 1.92. And so that's our number there, 1.92 to 1. So sometimes when you've got loads of calculations all everywhere, it's sometimes hard for the examiner to find the answer. Sometimes there's a space below to write it, or you can write it neatly. So I would go something like surface area to volume is 1.92 to 1. And I tend to, as you probably noticed, double underline answers to make it really clear. That's no doubt at all what my answer is there. Over the page. This works better in colour, so if you were looking at this on the computer, you'd see much better what these daft fruit flies look like. I've just put some colours on here to show you the colours of the eyes. This is a typical dihybrid cross, so when you do inheritance, you'll recognise this cross, and this cross tends to give you a 9 to 3 to 3 to 1 ratio. If there's nothing funny going on, if we're just using dominants and recessives and straightforward. So what's the ratio of each type of offspring resulting from this genetic cross? Well, it is a 9 to 3 to 3 to 1 ratio. You could look at this and actually count them up. We can go 9. So on this one, the greyish ones are the brown. So 1, 2. How many we got with brown and red eyes? 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9 there is brown and red eyes. And then we've got various, so sometimes I can get rid of these, make it nice and simple. And that one, and that one. Okay. Then we have got these 3 characters here. These are brown and black eyes. So brown and black eyes. I'm going to get rid of those now. Then we got 4 black ones. Well, only one of them's got black eyes. The rest of them have got red eyes. So there's 3 that are black and red eye. Those were those, that one, and that one. And then there's our last little fella, which is black body and black eyes as well. So black and black. So that's our ratio. Now, what fraction of the offspring are expected to have black bodies and red eyes? So black bodies and red eyes, that's that one, which is this one. Okay, so 3 of them. So there's 3, but what's the total? There's a fraction, is something over something else. What's the total? The total is, you can count these, or you can go 4 by 4, so 16. So 3 out of 16 have black body and red eyes. So that is 3/16. You could express that as you might ask for a decimal where you'd go, 3 divided by 16 and so on. But that's the answer there as a fraction. So we'll leave it like that. If it was capable of being cancelled down, like if it was 4/16, we'd cancel that down, but we can't on this occasion. Nearly there, folks. The RF value, again, when you do photosynthesis, you'll do a little bit about chromatography. Dividing the distance the pigment has travelled over the distance the solvent has travelled. I can immediately see the solvent there, and the origin is where it started, so the solvent has gone this distance here, and these are various pigments, and we can divide the two to get the ratio. So the diagram shows blah blah blah. Calculate the RF value of yellow. Yellow. Oh no, it's yellow green. Can't use that one. Yellow. Okay. And we tend to use the middle of the blob, or the middle of the furthest bit. That sort of distance there. So that's from the origin there. So there's 2 measurements there. We have got how far did the pigment go? How far did the pigment go? And so we're going right. Okay. Well, that's 20 millimeters there. That's 20 millimeters. If you look at the mark scheme, it says centimeters. I'm not going to use centimeters because they are sent by the devil to confuse us. And here we are 7 centimeters or 70 millimeters. Now I'm going to use that. 70 millimeters. And now our RF, dividing the distance the pigment has travelled. So distance pigment divided by distance solvent. So if you write it out like this, it will make it less likely that you'll make mistakes. So pigment 20 divided by solvent 70. And the examiner can see exactly what you've done. Sometimes there's 1 mark or 2 marks for the actual calculation, even if you screw up putting it into a calculator. So 20 divided by 70 is 0.2857, 0.2857142. But that's a silly number. What we've measured it to, I've measured it to 2 significant figures there. So I'm just going to try and do the same here. So equals 0.2. We're going to round that 8 up to a 9. And as it's a ratio, it doesn't have a unit. So I'm just going to underline that as my answer there. And I think we're there. That's the end of Maths Skills 12.